Okay, so today we are going to start with Newton's law of motion. We all know that Newton has given three laws. Newton's first law, that is law of inertia. Newton's second law, that is in this law, the second law, Newton has defined the force as rate of change of momentum, and Newton's third law, that is the action reaction pair. So we'll discuss about all the laws one by one. So before that, we need to understand what is force. So anyone can tell what is force? Means any kind of push or pull is known as force. Any kind of pull or push. Suppose on surface, if any block is kept and you want to push this block or you want to pull this block. So, so like this push and pull are known as force. This is your force. So force has a tendency to change the state of motion. Means if any body is at rest, then force will try to move that body. So to change the state of rest to a state of motion, or if any body is in motion, then if you apply force, then if you apply force in the opposite direction of the motion, then that force will create resistance to the motion and body will slow down. And depending upon the magnitude of the force, that will come to rest as well. Right? And so we, okay, fine. Now see, suppose any object is kept at rest. Initially, at time t equal to 0, it is kept at rest. And a force is applied to this. Who got disconnected? Ayushi and Saina together got disconnected. Okay, Saina got disconnected. Okay, and if you apply force on this body, so this force will bring this object in motion. Or if any object is in motion and you apply motion, suppose in this direction it is in motion, and if you apply force in the opposite direction, then depending upon the, so we are considering right now force is sufficient, so this force will stop this object. So it will change the state of the object from rest to motion or from motion to rest, right? And suppose if any any object is in motion, that suppose that object is going in this direction with some speed or some acceleration, and suppose if you apply some force on this, suppose you apply some force in this direction like this, making some angle with the horizontal or vertical. Now this force will do two different things. So if you break this force into component, one component along the motion, along the line of motion, so that will be F cos theta, and one will be perpendicular to the line of motion, that will be F sin theta. Now see, this component that is in the direction of motion, this force will increase the speed of the object because this force is supporting the motion. And the force that is perpendicular to the line of motion, this force does not have any significance right now, because when in the rotation we will study about this. Because if a component of the force that is perpendicular to the line of motion, this force will simply rotate, will change the direction of the motion. So force along the line of motion or opposite to the line of motion will increase the speed or decrease the speed. But the force that is perpendicular to the line of motion, that will change the direction of the motion, right? Okay, fine. Mhm. We all know the unit of force. So see, going forward, we'll definitely derive this force equal to m into a in second law of motion. But right now we can use to we can use this formula to check the units of the force. So what is the unit of mass? SI unit kg, and acceleration meter per second square. So kg meter per second square is the unit of force. This is also known as Newton. If How do we define Newton? If 1 kg mass is traveling with 1 meter per second square, so this is equivalent to 1 Newton. Correct? So SI unit of Newton, SI unit of force is Newton. But what is CGS unit? SI unit of force is Newton. But what is CGS unit? See,
Dynes.
dyne, yes. So see, we have this is our SI unit. So to convert this into CGS, this is centimeter, gram, and second. So convert this kg into gram. So this is 1000 gram, and meter you have to convert this into centimeter. This is 100 centimeter upon second will remain same. So this is 10 to the power of 5 gram centimeter upon centi square, a second square. So this is your dyne. This is called dyne. So this is also called 10 to the power of 5 dynes. So 1 Newton is 10 to the power of 5 dynes. 1 Newton is called 10 to the power of 5 dynes. Correct. So now, if see, basically there are 4 different types of forces. 4 different types of, broadly, if we categorize force, then basically there are 4 different types of category only. First one is gravitational force. Second is electromagnetic force. Third is strong nuclear force. And fourth is weak nuclear force. These 4 categories are have like it will include all kinds of forces. So basically we categorize forces into 4 broader categories. Now, first we'll discuss about the gravitational force. We already have studied about this in class, little bit about in class 10 or class 9, right? So this is by virtue of mass. This is by virtue of mass. We know that suppose you have 2 objects whose masses are m1, m2, and separation between their centers is r. So they will see both of these mass will attract each other. Gravitational force is always of attractive nature. So this is pen and this is another pen. So both of these pen will attract each other. Though this is not significant amount of forces, they do not apply significant amount of forces. So they do not pull each other towards each other, but they have tendency to attract each other. So we define gravitational force as G, that is gravitational universal constant, mass of one object, mass of another object upon r square. Correct. And G, this is universal constant. Its value is 6.67 into 10 to the power minus 11 um, Newton meter square upon kg square. Newton meter square upon kg into kg square. So this is the constant value that we have to remember. We have a separate chapter of gravitation in class 11. We'll study about that. Right. So this is also written as 20 by for calculation purpose. 6.67 is written as 20 by 3 into 10 to the power minus 11 Newton meter square per kg square. See, this is Earth. And what is the radius of the Earth? The radius of Earth is 6400 kilometer. Suppose any object is kept on the not exactly on the surface of the Earth, but at some distance. Suppose this distance is x. So suppose mass of the Earth is m, capital M, and mass of the object is small m. So they will have gravitational force F equal to G m upon r plus x whole square. See, if x is far less than r, because that distance may be like 1 kilometer, 2 kilometer, 5 kilometer, right? So if you compare this with 6400 kilometer, this is very small value. So I don't think like it is going to make any difference. So you can ignore r plus x can be written as r only. So this will be written as gmm upon r square, and this value is known as g. So m into g. So g is gm upon r square. The value of g, if you calculate, you will get 9.8 meter per second square, or we can roughly use 10 meter per second square as well. And this can also be written, sorry, this can also be written as pi square meter per second square, and like that. These are some facts that you have to note down. Then noted. Second type of force is electromagnetic force. We'll study about this in detail in class 12. See, as gravitational force is by virtue of mass, electromagnetic force is by virtue of charge. It is by virtue of charge. As this name suggests, it is like composition of two because of electric field and magnetic field. So gravitational force is always attractive, but electromagnetic force may be attractive or may be repulsive, depending upon the nature of the charge. Same charge will repel each other, and opposite charges will attract each other. So see, all contact forces falls in this category. All contact forces are called as electromagnetic force. All contact forces. We'll talk about more. Contact force means when objects will be in touch of each other. So now if we categorize this, so see, we'll categorize this electromagnetic force into different categories. Like if I talk about this normal force, see what is this normal force? So normal force is always of pushing nature. Normal force is always of pushing nature. See, suppose on table, this is your table, right? And on this table, one block is kept of mass m. So now if I ask you what all forces are acting on this object, then you can say that one force will be mg, that is force due to gravity, and other force. See, so because of this force, this object will try to move or will try to come down. So do you think like, this block will like, just penetrate this table and come down? No, no. So just to prevent this, just to balance this force, table will up, up, exert a force perpendicular to the surface. Table will exert a force perpendicular to the surface, and this force is known as normal force. So any two blocks that are in touch to each other, they will apply normal forces to each other. Like suppose on this ground, one block is kept here, another block is kept here, or one more block is kept here. Suppose mass m1, mass m2, and mass m3. Now, if you see, so like going to after some time, like we'll talk about free body diagram. So free body diagram is nothing. Free body diagram. So like when you will solve any problem of Newton's law, then first thing that you need to do is you have to draw the free body diagram of the object. Free body diagram means you have to identify all the forces and make the diagram of all those forces that are acting on the body. Suppose if I draw a video of mass m1, so FBD of mass m1. So FBD of mass m1. So you have to see which all forces are acting on mass m1. So see, on this block, one force is definitely working, that is force due to gravity. And other force that will be exerted by mass m2, because now this mass m1 is in touch with mass m2. So this mass m2 will apply a force to balance m1g. That is called a normal force between m1 and m2. Right? If I draw a video of m2, so a bit of m2. So see, mass of this block is m2. So gravity will act on this. That is m2g. Now see, this block m2 is in touch with m1 as well as m3. So this block m2 is in touch with m1 and m3. So m1 and m3 both will apply normal forces to m2. Now see, in Newton's third law, we'll talk about action reaction pair. So because m1, this m2 is exerting normal n1 to m1. So m1 will also exert same force. Suppose if I slap Archit, right? So he will get hurt. So I'll exert some force on his cheek. So his cheek will also exert the same amount of force on my hand. So we'll talk more about this action reaction pair in Newton's third law. But just to make you understand the how to identify the forces. So if block M2 will exert some normal force to M1, then block M1 will also exert the same amount of force on M2, but in opposite direction. So because M2 is exerting upward, so M1 will exert in downward direction like this. Now, M3 is also in touch with M2. So M3 will also exert some other normal force to M2. Now, FBD of M3. So M3 is in touch with M2. So how much force exerted by M3 to M2? That was N2. So M2 will also exert same amount of force to M3. And M3 is in contact with ground. So ground will also exert some force that N3 that is perpendicular to the plane, and gravity will work on this. So this is called like just making the diagram of all the forces is known as FBD, free body diagram. So this is normal force, and normal force is always of pushing nature. So it will always push the block on which it is acting, and normal force is always perpendicular to the surface which is applying. Okay. Now see, if I see this is your table or any whole kind of thing, and one spherical ball is kept over here like this. Now see this part is in touch with this corner, and this part is in touch with this corner. So this corner will apply a normal force N1, and this will apply a normal force N2. And because see, in circle we know that if this is normal force, it will pass through the center. So both of these forces will pass through the center, right? If on this ground, suppose a football is kept like this. So football is in touch with the ground at this point. So ground will apply the normal force here. Understand, guys? So normal force is always of pushing nature. You have to remember this. Noted? Second type of force is tensor. See, tensor, like suppose the ball is hanging like this. 1 minute. Tensor. Suppose a ball is hanging with the help of this rope, and this rope is tied with ceiling. Now, this is a string. This is your string, and we consider this string as ideal, means no mass, and this string is inextensible. It will not extend, or it will not break. So mass of this block is m. So now we can see that gravity will work on this ball. So it will apply force mg. So because of this force, this ball has to come down, but this ball is not coming because there is something. This is held by rope. So what rope is doing? So rope will exert some force that will oppose gravity. So rope will pull this block with some force that is called tension. So normal force is always of pushing nature, but tension is of pulling nature. So tension rope will always pull the object. So tension will always act away from the point of contact. and normal always acts towards the point of contact. Now, suppose if I take one example, like, okay, let me take, and third point is frictional force. I'll take example later. Frictional force. This is also called shear force or tangential force. See, one body is kept over here. Suppose at your home, sofa is kept, and small kid come and tries to pull that sofa, but that kid is not able to move that sofa. Why? Because whatever force kid is applying, that is not sufficient to move the sofa, right? And we come and just push that sofa and it moves. So what is the reason behind this? See, there must be some friction force between ground and the sofa. So the little boy, whatever force he applies, that is not sufficient to overcome that friction. So it sofa is unable to move. But we apply more forces that overcomes the friction force. So friction force always acts along the surface of contact. So this friction force, supposing this body is trying to move in this direction. So friction force will always oppose the motion, relative motion. Friction force always oppose the relative motion. So friction force will always acts like this along the surface of contact. F. So this is also called as tangential or shear force. And nuclear force, we do not have to study much about. Just definition, even definition is not required here because we know that nucleus, in nucleus, it will act in nucleus, right? We know that in nucleus we have proton and neutron. So protons are positively charged. They will repel each other. So if they repel each other, then they should move away from each other, right? So nucleus should kind of burst, and all protons will go away from there. But that is not the case. So there is some force that holds all the neutrons and protons. That is nuclear force. That's nothing else. We don't have to waste time in that. Now we'll start with Newton's first law. Newton's first law. That is law of inertia. One moment. So Newton's first law, that is also known as the law of inertia. Why this is called law of inertia? See, anybody. Newton's first law says that anybody, that is, anybody tries to, maintain its state of motion. Anybody tries to maintain its state of motion. Suppose any object is at rest. So if you want to make it move, then you have to apply forces on that, right? And if anybody is in motion and you want to stop that, so you have to apply force in opposite direction, right? So depending on the mass of the body, you have to apply different amount of forces. Suppose you want to stop a cycle that is coming at 10 meter per second. So you have to apply less amount of force, but you want to apply a truck that is coming at 10 meter per second only, but speed is same. But mass is different for both the objects, so you have to apply different amount of forces, right? So this law is known as a law of inertia. Inertia is, see, right now we'll study inertia, we'll consider inertia as mass only till we enter into the rotational mechanics. There we'll define inertia in different way, but right now we'll consider inertia is like directly proportional to mass. So inertia, so see, inertia is the property of any body, any object, due to which it has some resistance to change its motion. So I'll write. So inertia is, it is property of an object to oppose the state of motion. Like if any object is at rest, so it won't want to move, and if any object is in motion, it won't want to stop, right? So this is called inertia. So we cannot stop track because of its inertia, because its mass is very much, right? So higher will be the mass, higher will be the inertia. Higher will be the mass, higher will be the inertia, right? So what this Newton's first law says? So Newton's first law says that any body, any object wants to maintain its uniform motion or rest until some external force is applied to act on that body. Means any, you can note it down. So as per the Newton's first law, it states that any object wants to maintain its uniform motion. Any object wants to maintain its uniform motion or rest until some external force is applied. Until some external force is applied. So this is called Newton's first law. जब तक तुम उस पर कोई फोर्स नहीं लगाओगे, कोई भी बॉडी अपना जो स्टेट है वो मेंटेन करके चलते, वो उसका चेंज नहीं करने देगा. कोई बॉडी अगर रेस्ट पे है तो वो रेस्ट पे रहेगा, कोई बॉडी अगर मोशन में है तो वो मोशन में रहेगा, until you apply some external force. ठीक है? See, Newton's second law says that Newton's second law says that rate of change of momentum is known as force. I'll define that. So first we need to understand what is momentum. See, any object having mass m moving with velocity v. So momentum is defined as p. P is momentum. Momentum is defined as p equal to mass into velocity. So momentum is also a vector quantity because mass is a scalar and velocity is vector. So momentum has to be vector quantity. Now you can very easily define the units and dimension of this because you already know how to define units and dimension. I'm not wasting my time. So momentum is mass into velocity. Correct? So Newton says that rate of change of momentum. So dp. How do you find the rate of anything? We differentiate with respect to time. So dp dt, this is rate of change of momentum. That is your force. That is your force. And for longer period of time, if you want to find, suppose any object is moving with some velocity v in this direction at time t equal to 0. After some time, its velocity may become like something else at t equal to t. Then so initial momentum will be pi will be mv1 and final momentum will be mv2. So difference in momentum you can find P initial minus P final. So P final minus P initial, and then you can define force. So this force, whatever you will get, that is average force acting on the body during this time 0 to t. So that is change in momentum upon change in time. Correct? That is how you can find. But for a very small time, in dt time, like no, you have to find the force like this. The rate of change of momentum is this. Now we know that momentum is mass into velocity. Mass is constant, it will come out, and differentiation of velocity will give you acceleration. Now you can see from here we get force equal to m into v. Suppose you want to find force along x-axis. So for finding force along x-axis, you have to write this like this: mass into acceleration along x-axis. Or force along y-axis will be mass into acceleration along y-axis, and force along z-axis will be mass into acceleration along z-axis. Because acceleration is vector quantity and force is also vector quantity, so direction of force will be directly proportional to the direction. I mean, will be in the direction of acceleration only, right? चलें आगे, noted. Now suppose there is an object whose mass is suppose 2 kg, and this body is moving with some velocity that is function of time, that is 2t square I plus 5tj plus 10k meter per second. You have to find first find force on that object at any time t. How will you find that? Force is dp upon dt. So momentum is mass into velocity. Mass will come out, that is 2 kg, and d dt of velocity, that is 2 square I plus 5tj plus 10k. So just differentiate this. This is 4t I plus 5j, and this is constant, so will become 0. So this is 8t I plus 10j. Now you can see that x component of the force is 8t. That is depending on time. With time it will keep on increasing, but force along y-axis is 10 Newton, and force along z-axis is 0. So now if I ask you to find the force at time t equal to 5 seconds, so you'll simply put t equal to 5 in this, you will get that force, right? Noted?
Yes,
Now,
sir.
Newton's third law. So Newton's third law states that every action has equal and opposite reaction. Every action has equal and opposite reaction. If I slap you, you will slap me. If I slap Archit, Archit will slap me. No, Archit will not slap me. But Archit's cheek will slap my hand, right? If my hand slaps Archit, Archit's cheek will slap my hand, right? So if you punch on the wall, whatever force you apply on the wall will also apply the same amount of force on your, like a punch on a hand. So every action has equal and opposite reaction. So this is it. Nothing more than that in this. Right? Like I already told you. See, suppose this is table and body is kept over here. Now, if you draw, if you see, you know that this table for this body, like gravity will work down side, and table will apply a normal force to this body. Now, if you draw a video of this table, this body is in contact with table. So this body will also apply the same normal force, but in opposite direction. Understood? So this is action reaction play, nothing else. And I already told you about the free body diagram. Free body diagram is you just have to draw the diagrams of the forces that is acting on the body. Now, See. Now see, one point is equilibrium. Equilibrium. So there are two type of equilibrium: static equilibrium, and dynamic equilibrium. Dynamic equilibrium. Say static equilibrium. Static means at rest. At rest. At rest means velocity will be zero. But dynamic, so see, equilibrium means basically net force should be zero. Net force, F net, or sum of all the forces has to be zero. It means acceleration will be zero on the body. It means velocity has to be constant. So acceleration, if acceleration is zero, there will be two different cases. Either velocity will be zero or velocity has to be constant. Equilibrium means all the forces must nullify each other, must balance each other. So if net force will be zero, acceleration will be zero. And if acceleration will be zero, so there may be two different cases. Body either will be at rest or will move with constant velocity. So a static equilibrium means body will be at rest, means no velocity. And dynamic equilibrium means body will be in motion, but velocity will be constant but not equal to zero. Understood? So while solving an LM's problem, first thing that you need to do is you have to draw all the forces. Now, see, if uh, I'm just taking one example to how to tell you how to draw a BD of any body. See, there is an inclined plane. This inclined plane is making some angle with theta with horizontal. See, this is the wall. There is a block that is tied to this wall by a string. String is ideal, no mass of this string. So mass of the block is F. Now I want you, if suppose we want to draw the FBD of this block, then how will we do this? See, on this block, 1 mg will act, that is downward. This inclined plane will apply a normal force to this block, and normal force will always be perpendicular to the surface of contact. So this is the surface of contact. So normal force will be perpendicular to this inclined surface. That is normal. Rope is connecting with this body, and rope, you know that, always pulling nature. You can understand this body will have tendency to slide down. So this rope will prevent this body from sliding. So this rope will, not rope, don't call it rope, call it a string. String is very light, thin and light, means no mass. So if this string or this rope will have mass, it will have different tensions at different point. But right now we are talking about ideal string. So this string will prevent this body from sliding. So it will pull. So tension will always be away from the body. So one tension will be there. Now if you see, if I so this is the free body diagram. So means we have drawn all the forces acting on this body, right?
सर फ्रिक्शन है
Now, हाँ बोलो.
फ्रिक्शन
फ्रिक्शन नहीं अभी नहीं पढ़ रहे हैं. फ्रिक्शन का अलग चैप्टर है अपना.
ओके
After that there is separate chapter of friction. So we are right now we are just talking about the frictionless thing. There is no friction. Now if I talk about equilibrium, so suppose this is an equilibrium. I mean, of course, string is not going to be, it will not break, right? String will not break. So the block is not going to move. So block will be in equilibrium only. So if it is in equilibrium, so net force should be zero. So all the components of forces must nullify each other. So in this, we'll break all the forces in two components, one along this inclined plane and other perpendicular to the inclined plane. So see, if I break the component of mg, this is theta, this is 90, this is 91 theta, so this is theta. So this is mg cos theta, mg sin theta. Now this is in equilibrium. So see, force acting upward up the inclined plane must be balanced by force acting down the inclined plane. So T must be equal to mg sin theta, and force perpendicular to the plane must be like up and down, both has to be cancelled like, so normal must be equal to mg cos theta. That's it. So we just have to balance the force, right? Understood? And if I talk about the Newton's law of motion, Newton's law of motion for accelerating body, for accelerating body. So if I talk about Newton's, suppose you want to apply Newton's law of motion on an accelerating body, means body which is having some acceleration. So as per the Newton's second law, we understood force is equal to mass into acceleration. So if any body has any acceleration, definitely that body is experiencing some kind of force. So suppose this is the object. Suppose this is the surface and one body is kept over here. And suppose we apply some force over here. So this body is experiencing some force. So definitely this body will have some acceleration, right? So if body has some acceleration, it means that there should be some net force acting on that. Net force should not be zero. There should be some net force, right? Right. Suppose on this uh, inclined plane like this, on an inclined plane, this inclined plane is making some angle theta with the horizontal, one body is kept like this, having mass m. Now, question say that this body will move down with some acceleration a. Now see, draw the FBD, one normal, mg. Now break the component of, break this mg into two components, one along the plane of the, one along the inclined plane and another perpendicular to the inclined plane. So this angle will be theta. So there will be two component, mg cos theta and mg sin theta. Now question says that this body is sliding along the inclined plane. So this body is neither flying, neither going in this direction nor going in this direction. So definitely forces in a vertical direction has to cancel each other. So n must be equal to mg cos theta, n must be equal to mg cos theta. And see, there is no force that is opposing this mg sin theta in opposite direction. So this force is the resultant force in along the plane. So because of this force, this body will move with some acceleration. So this net force will be mass into acceleration. That is mm gone. So A is g sin theta. Understood? That is how we find. That is how we apply the Newton's law of motion on accelerating body. So I'm just quickly covering up theoretical part. There is nothing in the theoretical part. We just have to practice a lot. Correct. Now I'll give you some of the questions. So first question, I'll start with Aerodor. I would like if you guys give 2 minutes to just try. Just give your 2 minutes. Think about that. How would you solve this? Okay, Bolo. Any idea? See, I'll solve. Don't worry. Bro, any idea? Any luck? Arjit, Shaina, Ayushi?
सर मे बी इसमें जो अप्रोच लगेगा वो ये लगेगा कि मास जो है इनटू एक्सेलरेशन जो लग रहा है हमें सेम अपोजिट करना है उस चीज का, तो वो भी फोर्स मतलब उतना ही हमें
Okay,
लगाना पड़ेगा
yes.
उसके
See,
मोमेंट पे।
see, a balloon of mass m starts coming down with a constant acceleration. See, acceleration is not varying. Okay, so there is a balloon. Its mass is m. It is coming down with some acceleration a. Determine the mass to be thrown out from the balloon to move with upward. So, question says that how much mass you will throw out of the balloon so that a balloon will start rising up. Correct. The air drag is to be neglected. Now you see, on balloon, air will apply a buoyancy force. Air will apply a buoyancy force. So, right, as of now, just understand, like, no, just remember this, like, air will apply one buoyancy force. So, buoyancy force always acts vertically up. Vertical. So, this is the buoyancy force that air will apply on this balloon. You can ask question like, sir, this balloon is coming down. Then what is the need to apply this buoyancy force? Now, see. So, suppose from this balloon, you have thrown some mass. Suppose you have thrown some mass. So thus now suppose you have thrown m1 mass. So this mass is now m minus m1. So if you draw the FBD, this is mg, and here this is m minus m1g downward. Now after throwing up this mass m1, the balloon starts moving up with some acceleration a, same magnitude. But how? Net force is acting downward. Then how this balloon is moving upward? So there must be some force. That is called uplifting force. Uplifting force. This is also used sometimes. Uplifting force. So the same buoyancy force. Now this buoyancy force is taking this balloon up. Now you can see that, sir, here also FB and here also FB. Means buoyancy force will be same in both the cases. Yes, it will be same in both the cases because buoyancy force depends on volume of the body, not on the mass of the body. Buoyancy force is directly proportional to volume of the body. Buoyancy force is directly proportional to volume of the body. 1 minute. So buoyancy force is directly proportional to the volume of the body. So you are just thrown some mass. We are like we are not going to change the volume of the balloon. So buoyancy force will remain the same. Now in this case, if you see the body is moving downward, so net force has to work act downward. So what is the net force? That is mg minus fb equal to m into a. And here it is going up. So net force has to be in upward direction. B minus m1 into g equal to m minus m1 into a. We just have to solve these two equations. You will get what you have to get mass that has been thrown out. See, if you add
सर
these two
कैन यू
equations,
एक्सप्लेन अगेन आफ्टर buoyancy force cause my network is slow.
say if in first case, this is your first case and this is your second case. In first case, object is moving downward. So it is having acceleration downward. And we know that F equal to ma. So A is vector quantity and F is also vector quantity and F will be in direction of acceleration only, right? So if acceleration is downward, so net force has to be in downward direction. So there are two forces acting, FB and mg. So net force has to be in downward direction. So mg has to be bigger than FB. So mg minus FB, it means that net force downward direction and m into. Now here in this case, balloon is going up, means acceleration is in upward direction. So net force has to be in upward direction. So FB in this case, because we have thrown some object, FB has to be greater than this force. So FB minus this, that is equal to mass into acceleration. Just add these two equations. FB
Okay.
and FB will cancel, and this mg and mg will cancel. So this is m1g equal to this 2 times m minus m1 into, wait, अरे
फिर वहां पे एक्सेलरेशन ऊपर की तरफ कैसे लग गया सेकंड केस में?
बोल ही रहा है ना क्वेश्चन
अच्छा
कि thrown out so that the balloon with upward acceleration of same magnitude. Okay, we have to find m1 now, that is fine. So now see m1g plus this m1 will come over here and this is 2ma. So m1 take common and then 2ma upon g plus a. Understood? Hmm. Done? Okay. IUC and China, any
Yes,
problem?
sir. No, sir.
Understood.
IUC and China, you don't want us to see you?
Sir, I'm getting disconnected today. That's why I've not switched on my video.
China,
So I'm still at my grandmom's house, so there's not a good
oh,
back.
अच्छा.
Yeah. So when I
Okay.
get home, I'll switch on, sir.
Okay.
So also from 7th to 13th, I won't be able to join class, but I'll look at the recording, sir.
Okay, fine. Where are you going?
So we're going to the Andamans.
Oh, wow. Done. Okay. Now, this is the vertical wall. This is the inclined plane. This inclined plane making some angle with horizontal, that is angle theta. And suppose one spherical ball is kept at rest here, like this, at rest. The mass of the ball is m. You have to find normal forces applied by wall and inclined walls. If the spherical ball, if the spherical ball is kept at rest. So,
So only two, sir. Like wherever wherever it's touching with the.
yes. Normal force always act at the point of contact.
सर आंसर न्यूमेरिक वैल्यू में है।
नहीं नहीं, न्यूमेरिक नहीं है।
सर फिर n1 cos थीटा प्लस n2 sin थीटा।
नहीं नहीं, इतना आसान भी नहीं, थोड़ा थोड़ा बड़ा है। नहीं। मैं करता हूँ, करूँ।
एक मिनट सर।
हाँ, अच्छा कुछ ऐसे मतलब देखो, N1 और N2 तुमको निकालना है, तो आंसर में N1 N2 तो नहीं हो सकता ना। वो कैसे होगा, बताता हूँ।
सर इंक्लाइन के, अच्छा पहले वॉल के साथ मुझे आया
यस।
mg sin थीटा cos थीटा।
देखो, यहाँ एक कॉन्टेक्ट है, दिस इज वन कॉन्टेक्ट एंड दिस इज अदर कॉन्टेक्ट, सो दिस वॉल विल अप्लाई सम normal force, and this wall will inclined plane will also apply at this point some normal force. And we know that these are the normal forces. So definitely in circle, you know the property. If this is the tangent and say radian, if this is 90 degrees, so this will pass through the center. So this normal force N1 and this normal force N2, both will pass through the center, right? And now, and you know, mg will also work. Now you just have to, because you know this ball is at rest, so you have to balance the forces. So break this into component, like vertical and horizontal like this. Anyway, so just break this into two component, this normal force and two like this. Now see, this angle is theta. So this angle will be theta. So normal is this. So this angle theta. So this angle theta. So this is normal. So this will be normal N2 cos theta, and this will be N2 sin theta. So see the forces in the vertical direction. So N2 cos theta up and mg down. So N2 cos theta equal to mg. So from here you can find N2 equal to mg sec theta. And if you balance forces along the horizontal direction, so N1 towards left and M2, sorry, N2 sin theta towards right. So one is towards left and other is towards right. One moment. Right. So just put the value of N2 here, that is mg upon cos theta into sin theta. That's it. Right? That is all. देख रहे हो, बच्चा भी पकड़ना पड़ता है पढ़ाते पढ़ाते। डन, चले आगे। This question, try this question. उन लोगों को नहीं समझ रहा है, ये समझ रहा है. Do you understand the meaning of breaking of the plane? Anyone? See,
हाँ
let me
सर,
solve it.
वो F का वर्टिकल कंपोनेंट mg से ज्यादा हो जाएगा.
See, I'll draw the FBD first. So this is your body M. So it will experience one force due to gravity, one force that is normal due to this plane, and one force that is F at some angle alpha. Now you see, break कर दो इसको component में, two components, F sin alpha. See, okay, body. Now you can see that this F is a function of time. So with time, this F will keep on increasing. So if this F will keep on increasing, this component will also keep on increasing. So after some time, this force will be bigger than. Suppose if I talk about the equilibrium, so what will happen at equilibrium? So this N force in the vertically up direction, N plus F sin alpha must be balanced by mg. But with time, this force is increasing. So after some time, like this force will be enough, so that this block will leave this ground. So there won't be any contact between this block and the ground or the surface. So kind of block will start kind of will start flying kind of like this. So this force will lift this block like this, and even after some time, this block will start flying, right? So there won't be any contact between this surface and this block. It means that it will break, the contact will be broken, right? So means once there will be no contact between this block and the surface, this normal will become zero. This normal will become zero. So after some time, so it is asking so you have to find the body, okay, velocity, okay. So first you find at what time this normal will become zero. So at that moment, it will break off the contact or the plane. So put the value of F, that is KT sin alpha, that is mg. So this T equal to mg upon K sin alpha. So after this time, this much time, the block will break off the plane, right? The contact will be broken. Now you have to find it at this moment. Suppose this is T now. So at this moment, when contact will be broken, then at that moment, what would be the velocity of the block? So first you have to find. Now you can see that force is dependent on time. So force will keep on varying. It means that if force will vary, acceleration will vary. So acceleration is not constant, right? So you cannot apply v equal to u plus at or s equal to ut plus half at square, because those formulas are applied when acceleration remains constant. Now here acceleration is varying. So you have to use integration process. How you find this? See. Now you can see that what would be the velocity. So till this time, the block will move towards right because of this component of the force, that is F cos alpha, that is mass into acceleration, and F is what? KT. So KT cos alpha equal to mass, right? This acceleration is dV by dt. Now cross multiply this K cos alpha out T into dt m dV. Now integrate this. Constant will come out of the integration. So initially it was at rest when time t equal to 0, and after time t, so how much time t? This t now, because at this moment when this will break down break the contact, at this moment you want speed. So at time t equal to 0, time t equal to t naught, suppose the velocity is v. Now this you just have to integrate it. So this is t square by 2. So lower limit is 0, upper limit is t naught, and this is v 0 to v. Now if you see, so mv is k cos alpha t naught square by 2. Now you just have to put the value of t naught over here. So v will be k by 2m cos alpha, and t naught is m square g square upon k square sin square alpha. Now you can see K and K cancel, M and M cancel. So this is G square M cos alpha upon 2K sin square. Mg square cos alpha upon 2K. Understood? Did you understand the concept? Everyone, I say
Yes, sir.
Saina.
So I'm just copying it down. If I don't,
Okay,
so
okay.
can you explain
You-
the last step again?
Where? Here? Where?
After we multiply cos theta. So how did you get V?
Expression is dB by dt. Rate of change of velocity is expression, na?
No, so you got mv equals k cos alpha t square by 2. So can you explain it again?
So how did we get this thing? See, after integration, this is called lower limit, this is upper limit. So you just have to put the upper limit first and minus lower limit. So put a V here and then minus 0. This is this. And here, you know the integration of dx?
Yeah, got it, sir.
Got it? Okay.
Yeah.
Noted. Done. Shall I move ahead? Okay, now
Yes.
for the second part, you see, you can see that in second part, it is asking about the you have to find distance traversed by the body up to this moment. So up to this moment, like when it will break off. So for this time from 0 to t naught, you have to calculate how much distance it will travel. So see, because the acceleration is not constant. So again, you have to use integration here. So how will you solve this? See, so instead of putting t naught, now see here, I'll just change from here. So up till here, things will remain same. Now from here, k cos alpha will be of t into dt and then m into dv. Now I will just integrate at a time t equal to 0, body is at rest, so 0 velocity, and at some time t, or you can say that, okay, and for
Sir,
at some time, suppose velocity is v.
सर वेलोसिटी को डायरेक्टली डिफरेंशिएट किया तो
वेलोसिटी को डिफरेंशिएट किया तो डिफरेंशिएट क्यों करोगे इसको?
मतलब इंटीग्रेट किया तो
नहीं, वो तो उससे नहीं आएगा ना। तुमको एक्सलेशन को v dv by dx कर सकते हो।
हाँ
तो ये हो जाएगा k cos alpha t square by 2 upper limit t lower limit 0 m v upper limit v lower limit 0. So k cos alpha t square by 2 lower limit 0, if you put, you will get nothing. So this is mv. Now this mv can be written as dx by dt because you have to find distance. Now again cross multiply k cos alpha t square by 2 into dt equal to m dx. At time t equal to 0, no distance traversed. At time t naught, some distance will be traversed x. So k cos alpha into, see, half will come out, t square, integration of t square is tq by 3. tq by 3, upper limit t naught, lower limit 0. M into x, upper limit x, lower limit 0. Now you can see that k cos alpha by 2 into T naught cube by 3 equal to m into x. So k cos alpha upon 6 at T naught is how much? This thing. mg by k sin alpha. mg by k sin alpha. mg by k sin alpha. Whole cube equal to m into x. So k cos alpha upon 6 m cube g cube k cube sin cube alpha equal to m into x. M 1m will be gone. This. So total distance would be cos alpha m square g cube upon 6 k square sin cube alpha. Let me check the answer. Oh yes, matched. Understood, guys? If anyone has any doubt, please ask me. Don't hesitate.
Sir, how did we substitute T cube?
How did we substitute k cube?
No, sir, T naught cube.
Oh, see, you know the integration of x raised to n dx. That is x raised to n plus 1 upon n plus 1. So here n is 2 will come out. So n is 2. So 2 plus 1 upon 2 plus 1. And then put
Okay.
upper limit first. You have to remember this formula.
And then, sir, mg by k sin alpha.
So from here, no? Because it is asking like you have to find the distance traversed until it at the moment when it will break off the plane. So at this time it will break off the plane. So for this time, so put t equal to t naught, value of t naught from here.
Yes, sir.
Noted? Giving you second question. One moment. Here is the second question. Try this. समझ में आया तुम लोगों को कि नहीं आया? बोलो, नहीं आया? सुनो, a bar of mass m resting on a smooth horizontal plane. See, smooth means there is no friction, mass is m, it is at rest, and it starts moving due to force. One force mg by 3 is applied here. So force is constant. In the process of its rectilinear motion, and the angle alpha between the direction of this force and the horizontal. Okay, so magnitude is constant, but direction is, so at some angle this force was applied, and that angle alpha is like, varying like this, k into s. S is the distance traversed by the bar, like, the more distance it will travel, alpha will be more. So find the velocity of the bar as a function of angle of alpha. That's very simple now. You just have to break. First you draw the FBD. See, if you draw the FBD, you will see this surface will apply a normal force, gravity, mg, and this force. Break this into two components. That is, F means mg by 3 into sine alpha, and this is mg by 3 into cos alpha. You can see that this block is having no motion along vertical. In a vertical direction, it is not making any motion. So force vertically up. So net force along the vertical direction must be 0. So force that is acting up must be balanced by the force acting down. And only one force, that is in the horizontal direction. So it will provide you the motion, and that is equal to mass into acceleration. Now you can see that, see, mass will cancel. This m cancel. See, g by 3 cos alpha is varying. That is ks. Alpha is k into s. That is, and a can be written as v dv by ds. Now just multiply and integrate. G by 3 cos ks into ds equal to v dv. Integration. At initially it was at rest, so velocity was 0, distance was 0. After some time, so 1 minute, as a function of angle alpha. Okay, 1 minute.
बस डिस्टेंस के साथ साथ एंगल इंक्रीज हो रहा है, तो एक पॉइंट आएगा जहाँ पे नॉर्मल रिएक्शन 0 हो जाएगा ना.
Again, yes. Again, we have to apply that same concept. At what point, like, it will break the contact, right? The KS, okay, no, but that question does not say that, like, okay, 1 minute. So this will be like this. Now, G by 3. So suppose now this distance is S. So integration of cos is sine, and angle will remain as it is. And now you don't know that the coefficient of S is K. So in integration, we will divide by coefficient. And upper limit is S, lower limit is 0. That is V square by 2, and then V and 0. Put here G by 3 into K, sine, put S here, Ks, and then put S equal to 0. So sine 0 is 0 now. This is V square by 2. Ks is your alpha. Alpha is Ks, na? Alpha is Ks. So just put here G sine alpha upon 2, 3K square root equal to V. Is this your answer? Yes, 2G sine alpha by 3K, correct. Because question does not talk about the breaking of the plane, so we cannot take that thing. Everyone understood?
Sir, how did we
Priyanji.
integrate cos ks?
See, cos, so integration of cos is sine, and then so like we do differentiation. So differentiation of one function at a time. So integration may be y. So integration of sine cos is sine. Angle will be as it is, and then we can see that we are differentiating with respect to s. So k is the coefficient of s. So whatever coefficient we have, by that coefficient we will divide this. This is the general rule.
Okay, sir.
Done, everyone? Next easy question. This is the ceiling. One block is like tied with a string. Different block. This is 3 kg mass. This is 2 kg mass. System is at rest. System is everything, like complete both blocks. System is in equilibrium. Find tension in both the strings. See, because now we are considering ideal string. So in one string, tension will be same at all the points. But if strings will be different, so in different string, we'll consider different tensions, T1 and T2. Solve.
So would it just be first one will be 20 sorry 50 newtons, and for the other it will be 30 newtons.
Everyone got? Archit, Ayushi? Archit, Aya?
नहीं सर कर रहा हूँ।
देखो, Ayushi नहीं आया ना? देखो, you just have to draw the FBD. So for this 2 kg, you can see that for 2 kg, so this string will have some tension. So this is tension T1. This is string number 1. This is string number 2. So this will have a tension T1. And there is one more string connected to this body. So tension is always of pulling nature. So this rope will try to pull this block. So this is T2. And mg will also work. That is 2 into g. And if you draw the FBD of 3 kg, you can see that mg will work downside, and this is string 2. So T2 here. So in this string, like at all points, tension will remain same T2. So for equilibrium, T2 is 3g. So this is 30 Newton, G is 10, and here T1 equal to T2 plus 2g. So T2 is 30 Newton, and this is 2 into 10, that is 50 Newton. Understood? समझ में आया? आयुषी और अर्चित?
यस सर।
Yes, sir.
हम्म। Try this.
So do we have to find the frictional force in this?
Oh, it's a my bad. Sorry. By mistake, I gave you this. I did not see like read this question. No, ignore that, please. Sorry. Okay, let me give you another question. This is the ceiling, and these are the two different ropes, and here from third row, one block is hanging like this. The mass of this block is 10 kg. This angle is 37 degree. This angle is 53 degree. Ulta. This is 53 degree. This is 37 degree. And this is rope number 1. This is rope number 2. This is rope number 3. So you have to find tension in all these strings. System is at equilibrium. System is at equilibrium. If system,
So we can just use a sine rule here, right?
you can apply that Lami's theorem, but Lami's theorem is sine rule that applies only when only three forces are acting. So don't use that frequently. Like use basically you just have to draw the APD and then break all the forces into component and then balance. Take some as zero. then find and tensions in all these strings. All the
So for tension and one, it will just be 100 newtons, right?
I need to solve. See now, we just have to draw the FBT. Just have to draw the FBT.
So if we
See,
draw the FPD, can we just assume that the x component for each of the forces is the tension?
yes, yes. So you can take X like this, X and Y. So mg, so 10 into G, that is 100 Newton downside. String 1, so tension will be different here. See, and this is the point here, like there is a knot here. So these two are different, these three are different strings. So they, all of them will have different tensions. So T2 and here T3. Now you can see, you just have to balance this. So this is 53, this is 90. So this is 37 and this is 53. See, you can see 37 here. You just break into components. So T3 will have T3, this is 37. So sine 37 and this is T3 cos 37. And if you break this T2 into components, so this is T2 sine 53 and in vertical direction, it's T2 cos 53. These two components will add up. So now you can balance the force in horizontal direction and vertical direction. In horizontal direction, this will be nullified by this. That is T2 into sine 53, that is 4 by 5 equal to T3 sine 37, that is 3 by 5. So 4 T2 equal to 3 T3 in
सर
vertical
आंसर
direction.
बोलूं
Sorry,
आंसर बोलूं
एक वो हल्का है तू कर देख. So here is not. So T1 will remain will be same here. Tension in this string. So here also T1. So in vertical direction T3 cos 37, that is 4 by 5 plus T2 cos 53, 3 by 5 must be equal to this T1. And
75 Newton and 25 Newton.
nahi, and this T1 must be equal to 100 Newton. तो यहाँ से T1 ये हो गया, तो तुमको देखो यहाँ से 4T3 plus 3T2 must be equal to 5T1 and 5T1 and the T1 is 100. So this is 500 Newton. Now you can replace T3 as like this. So 4 into 4T2 upon 3 plus 3T2, that is 500. So this is 25 T2 equal to 500 into 3, that is 60 Newton. And if you put here, so you will get T3 is 4 by 3 into T2, that is 60. So 80 Newton. So 100 Newton, 60 Newton and 80 Newton. But if you understood or not.
Yeah, so it's just simple if you just take the x component.
I did the same thing, na?
No, but then none of the calculation is required. You can just
Now,
use.
how will you solve? How will you solve that?
So just 100 in for T3 100 sine 37 and for T2 100
Ah,
sine.
correct. You can also do in 1 or 2 line. You just have to break that force along the row. That will work. But I'm telling you the correct, I mean, the correct method that will help you going forward.
Okay, so
Those are the shortcuts. I don't use that like in those shortcuts. Noted, everyone? Done? Chalo, one last question for today. And this is a very good question. Bro, this is your question. I mean, the question that I sent you, right? Okay, I'm just giving you 1 minute to go through just to read the question. Don't try to solve it. I'll solve it.
सर अगर रोप hangs 200 kg, so how does it start with 250 kg?
That is why this is good question. रुको रुको इनको पढ़ने दो ना एक बार. Okay, see, I'll solve the question. A weight of 200 kg hangs freely from the end of a rope. The weight is hauled up vertically from rest by winding up the rope. See, suppose यहाँ पे rope is winded up, kind of. Here, this body is like 200 kg at rest. And the pull starts at 205 kg. Suppose someone standing here, from here, this guy is trying to pull this. So he will apply, suppose if you correlate this question, so you can consider there is a block that is hanged. Oh, sorry, that is hung hung up. So initially the mass of the block is 200 kg kind of. So this block will provide the pull, right? So if you multiply this mass with G, you will get the force. So initially this was the pull, and it constantly diminishes uniformly at the rate of 1 kg per meter wound up. So find the velocity after 30 meters have been wound up. Suppose if 1 meter wire rope will be wound up, in that case the pull will decrease by 1 kg. Means if you multiply by G, you will get force. So suppose if x meter will be wound up, if x meter will be wound up, then how much this pull will decrease? X kg. So initially it was 250 kg, but after if x meter will be wound up, so kg will be decreased. This pull, if you multiply by G, you can get the force. Now pull is acting upward on this block, because if I pull this speed, this will be transferred to this block. This block will go up. So this pull will be acting upward, and gravity is constantly working downward. So what would be the net force? So pull minus this, and that is equal to how much? Mass into acceleration. That is v dB by dx. Now, so mass is 200.
So-
Yes, ma'am.
So you subtracted minus 200 grams. Shouldn't we do it in newtons?
No, not this is not gram. This is G, mg.
Oh,
This is kg.
Okay. No, but
So
sir, even then, if it's 200 kg, shouldn't we have 2000 newtons?
no, kg. Force is mass, and sorry, gravity force is mg. M will be in kilogram.
Okay,
That
okay.
is
So,
SI unit.
oh, you just wrote G. Okay, got it.
Yes, G means 10. Right. Now you can see that this is 200 V into dV into upon dx. Now this 250g minus 200g, that is 50g means 500, and minus this is gx means 10x, and into dx. So you can see that 1010 will be gone. 20 into vdv equal to 50 minus x into dx. Now it is saying that you just have to integrate this. When x is 0, no velocity. When x is 30 meter, some velocity. So this is 20 into v square by 2, and here 50, and then integration of dx is x, and put the upper limit 30 and 0 minus integration of x is x square by 2, put upper limit 30 into 0. Now solve it. So this is 10. So 10 into v square equal to 50, then put 30 minus 0, and minus this is 900 by 2. So 10, 10, 10. So v square is 150 minus 45, that is 105. So v is under root 105 meter per second, and your answer is also 10.5 into g, that is 10.5 into 10, that is g. You can take 10, 105. Understood? So this is how we can solve. Abro, you're all right? समझा?
हाँ हाँ
Done, sir.